Hello, Yawning Angel, back again, back on the AMOS trail, and this is a short AMOS video. This video is all about me telling you about a freely available, free to download utility which I've made available, and that utility will get the hexadecimal values for your color palette within your programs, and also give you another way to load hexadecimal values into your default palette command. So let's take a deep dive into the code and let me show you all about it. So it was while I was writing the code for this program here, which will feature in a future video, that I realized I needed to set the default palette based on the palette from the bobs which I'd created using the object editor. So I dug out the code from a previous program that does this, link up above, and then I thought to myself, hang on, lots of people should be able to make use of this. I'll make this a standalone utility. So that's what I've done. And now what we can do, you know how this works, we can grab a brew and dive on into the code, and I'll show you how it all works. Okay, time for a mouthful of tea. Tea from a new mug. Big shout out to Chris and the Skulls from channel Is It Any Good? Keep up the good work, guys. Love your material. With that said, let's get on with this. Right then. Here we are in Yawning Angels Utils program number 2. Yawning Angels Utils program number 2. There was a Utils program number 1. Link for that is up here. This code is available to download from my website. Bit of blurb here, the usual thing, code supplied by me. There's probably a better way to do it. I'm not taking any responsibility if this damages your system, blah, 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 blah. But if you follow my videos regularly, you know my code is usually quite sound. Link to my website down here. Link to the downloads page will be given in the description down below, and also there's probably a link floating around on the screen now where you can download this program. If you like what I do, you can support me on Ko-fi. A number of you have already, and I love you people out there for doing it. Thank you ever so much. Right, I'm going to run this program. So what it does then, first thing it does, it asks for the number of colors that I want it to go and get the hexadecimal values for. 2 colors, 4 colors, 8 colors, or 16. I'm not covering 32 because of reasons. Also, if you're doing stuff with bobs and sprites and whatever screen resolution you're using, you probably really want 8 or 16 colors. Yawning Angel, why 2, 4, 8, 16? The object editor gives us those resolutions that we can have that number of colors for, so that's why I've gone with those numbers. So I'm going to say, well, get me the value, the hexadecimal values of my 8 colors. And so it goes off, and for the original color palette, which is what we're seeing now, colors 0 through to 7, so 8 colors, these are the hexadecimal values it has returned, and it shows you what the color is in the background. Now, the next bit, you will need to add in the name of the .abk file for your bobs and sprites, or the .iff file, in order to get the palette for that, and load that into this program, and so it can show you those hexadecimal values. I am providing an ABK file with a couple of bobs in it, and that will change the color palette. So when I press enter now, what the code will do is load in my ABK file, and the color palette changes. Got a couple of the bobs here just to show that it has actually loaded those in, and it says external color palette retrieved. Because it's loaded in the ABK file, and it's done a get palette command. And now you'll notice my hexadecimal values have changed from the original. The colors have changed, obviously. So we're not seeing the original colors, but we can still see the original hexadecimal values. And these are the new hexadecimal values for the new color palette. And now what it needs to do, it can take those and it can now set our default palette for the program to have these hexadecimal values. So what it does next, what I've got the program to do, is take these values here and load them into an array. So I've defined an array, and these values are now sitting in an array. What the program will do next is take the values from this array and load them into the default palette command. So you don't have to. You just got to put the code in. It's a little bit clunky, and I'll show you when we get into it, but effectively it's going to take that array, press the key again, it's going to load it in to the default palette, and now I just run the commands that I use to get these just over the palette again, just to make sure that we're okay. And we can see that all these values here all match up, and they're all different from the original palette. And like we say, it says down here, color palette has been updated, press any key to exit. And that's really all there is to it. If I run the program again, I can do this for 16 colors, and it does that. That's the original palette. There's the new colors. There's the array. There's just our test. We've run over the color palette again just to make sure the palette within the AMOS program has got the right values in it, and it has. And that's all there is to it. Let me just quickly show you what happens if I do 2. Yeah, it's just returning those values, and that is it. Yawning Angel, what happens if you put in another number? Say if I want to do 5, well, you can key in 5 and it won't do anything. Key in 7, it won't do anything. 15, it won't do anything, because it will only let you key in 2, 4, 8 and 16. Yes, everybody, that's what validation is all about. Right, let's get into the code proper, and I'll explain things as they happen in there. Right then, in the code. So what are we doing? This is a quick whistle-stop tour through this code, because there's nothing in here that you haven't seen before, apart from arrays. We haven't covered arrays. Right, so we open a screen, 16 color screen, high res, basically screen housekeeping message up there. We've got a do loop here, which basically asks us for our number of colors, that's our input. And here we're checking 2, 4, 8 or 16 colors. That's all we're allowing to key in. Some more screen estate. And then what it does, it just runs this for loop. So however many colors we've put in, we just run this for C equals 0 to HC hash. HC hash is the number, -1, and of course then that goes off and gets the relevant colors. It puts them on the screen, paper command there, it will be the color that is returned, and there's just a very simple little bit of housekeeping here, that if the color ink is the same as the paper, or the pen is the same as the paper, we just swap it over so you can actually see, so you don't get like a brown background with brown text on it. And then essentially we just print a space after the number, so we'll have color 0 space, and then we'll have the actual hexadecimal value, and this is it, the print command, print hex $color C3, and that's it. That's really all we're doing. Then we've got a wait key command, and this is the bit here where you're going to need to make changes. So if you're loading bobs and sprites and IFF files, this is the bit where you need to change. So I've got this load command here, so load, and I've just got this ABK file, ya_logos.abk. You need to replace this with your own ABK file or your own image file. Then you need to get the color palette associated with that. So I'm getting get bob palette because I'm using bobs. If you're using IFFs, you need to use the appropriate get palette command, etc., etc. So this bit here, this is where you make your changes. Once you've done that though, the rest of it's all gravy, because then it shows us what the, it tells us the external color palette has been retrieved. It just dumps a couple of bobs on the screen. I just did that as eye candy, just to prove that it has retrieved stuff from the ABK file. And then we just do exactly the same command again. I probably could have put this in a procedure, and we just got to call it each time. But this is quick and dirty code. We just do the same for C equals 0 to the number of colors that you want to check -1. And we just go through and we do that print hex $color C blah, blah, blah. And then in the second bit though, we load each value into an array element. Please note here on this line 89, I've got a dim statement for our array. So dim HC $ brackets HC hash. So however many the number we put in, whether it's 2, 4, 8 or 16, this is how big our array will be. And our array is HC $. So down here for each element in HC $, I put in the hex value for the color. So it's pretty much like we're doing the print here for the hex $ color. I'm just using that same command down here to load that value into an element in the array. And the size of the array is defined by the number of colors which we are looking to retrieve the hex values for. I hope that makes sense. So once it's done that, it just dumps those array values on the screen. So it just iterates over that array. So it just does for 1 equals to the number that you're looking for. So 2, 4, 8, or 16. Goes over that array, print $, and it prints each element out. There's a wait key at the end of that. And then what we have to do is set our color palette now from that array. And I'm doing it for 2 colors, 4 colors, 8 colors, and 16 colors. And each line is pretty much our default palette will be the value of what is in each element in that array. So the first element of the array, we take what is the value of $, which is our array, value 1. And that hex value will be loaded into the first position for our default color palette. So that's for 2 colors, this is for 4, this is for 8, and this is for 16. I tried to find an iterative way of doing this, and I couldn't. So if somebody else can, crack on. But this is, like I said, quick and dirty. This just does it. This just loads those new hexadecimal values into our default palette. Then we update the screen, and then literally we just run that same loop again, that print hex $color. We just go over again just to make sure that we've actually got those array values loaded in correctly. It just prints those to the screen and then ends the program. Job done. So what you can do in your programs, you can probably just take, to get your hexadecimal values, you can take this piece of code. Obviously you'll know how many colors you have, so you won't use the HC hash variable. You'll just have, 0 to 16 or whatever. And that's literally all you're going to do, is just iterate over all the colors in your existing palette and use this print hex $command to print them out. When you've got that, you could then assign those to an array if you wanted, and then just dump them in to your default palette. It's it's a bit Heath Robinson, it's a bit scratchy, but it does the job and works quite well, and I am quite pleased with it. So that is that. Some of you may be asking, on this loop, Yawning Angel, why are you doing for c equals 0 to HC hash -1? Okay, so if I was looking for 16 colors, this would be from 0, c equals 0 to 16. And we know that in memory, our colors are stored from 0 to 15, giving us 16 colors. That's why I have to do a -1 each time. So it takes that number back. So this would actually read c equals 0 to 15. But because HC hash is 16, because that's what I've keyed in on the screen, I need to subtract the 1 from it. So it picks up the right colors from the right locations. Trust me, it works. I've tested it. It's all good. Huzzah! And that is it for another video. Thank you ever so much for watching. Really appreciate it. Hope this is of some use to you. Let me know in the comments down below. Don't forget, go to my website and download this link here. I can be found on the socials and various stuff, Ko-fi and all the rest of it. Links for that in the video description. Right, so that is it for this video. We'll be back on the AMOS trail. We're going to be doing some really exciting stuff, as I kind of hinted to at the beginning of this video. But until then, whatever you do, look after yourselves and keep it retro.